Good morning, students. In the last class, we discussed about the quantum numbers. Okay. So in that, four types of quantum numbers are there. One is principal quantum number, which tells about what? Main shell. Understood? Next, it decides the size of an atom. Second one is azimuthal quantum number. Azimuthal quantum number tells about subshell, means shape of an orbital. Okay. Third one is magnetic quantum number that tells about orientation of an electron, means where exactly the electron present. Okay. Next, the fourth one is that what is that? Spin quantum number, which tells about the spin of an electron in clockwise and anti-clockwise. Clockwise means plus half, anti-clockwise means minus half. Plus or minus half will be. So if any particular orbital they given, then how can you find out the spin of an electron? Okay. So listen, I'll write here. For example, 2p4 the given. Okay, 2p4. So in this 2p4 orbital, you have to find out the four quantum numbers for the last electron. Initially, 2 is there, p is there. P means how many orbitals are there? 3 orbitals are there. For p orbital, 3 orbitals are there. Okay, this one is what? -1, 0, +1. Correct? So this is the first electron, second electron, third electron, fourth electron. So to the fourth electron, we need to check the four quantum numbers. Means for this electron. So numbers are, one is principal quantum number, another one is azimuthal, next one is magnetic, last one is spin. Okay. So what is n value here? Principal quantum number 2, because the number represents the main shell. L value 1. Why? Because this is p orbital. For p orbital, L value is 1. Okay. Next, m value. So to which electron we are counting the? Sorry, we are considering the quantum numbers here for the fourth electron. Fourth electron present where? Here. So that is what? -1. Magnetic quantum number value is -1. Okay? And ms, that is spin quantum number. So the fourth electron is in opposite spin. So that is -half. Understood? If the same thing is calculated for third electron, then what must be the n value is 2 same? N value is 1, that is same, but m value changes. M value is how much? +1. And the ms value is +half. This is how to find out the quantum numbers, different quantum numbers for the particular orbit. Understood? So the next is, so you know what is the drawback of the Bohr's atomic model is, it doesn't tell us about the shape of the molecules or shape of the orbitals. But this quantum mechanical model successfully explains the shape of a molecule or a shape of an orbital. SPTF orbitals are there. Those shapes are explained by this quantum mechanical model. So now we will discuss with the shape of a molecule or shapes of orbitals. Total 4 orbitals are there. First one we will discuss s orbital. What is the shape of s orbital? Spherical. Means round. Okay. So in this spherical, means s orbital is there. Orbitals are those where the electrons are present. Electrons present where? Around the nucleus. So this is the nucleus. Okay. So around the nucleus, assume this is one s orbital. Understood? So So this is the nucleus, this is the s orbital. Students, here the electrons are present. This is what? One s orbital. If we consider 2s, this is 2s orbital. Similarly, this is 3s orbital. S means it goes on increases as the number of shells increases. 1s, 2s, 3s. But it is spherical in shape. Sphere. Completely sphere. So the electron is like a cricket ball. So the shape of this s orbital is also like a cricket ball only in a sphere. So the electrons can revolve around all over the sphere. So sphere that is like this, the electrons will move from all over. It is a three-dimensional movement. We cannot see it on, show it on the board. Okay, so this is the sphere assumed. So electrons may be here, they're completely revolving like this in a different path. Of course, particular path. Okay, for 1s, this is the path. For 2s, this is the path. For 3s, this is the path. Okay, are you getting? So the electrons in the 1s section revolving in 1s, stationary orbit, I told you already. They are revolving in a particular path. That path is called as stationary orbit or orbital or a shell. Understood? So those are revolving. So here where the electron density is more. Understood? So students, remember in these shapes two concepts are there. One is radial node, another one is radial node, another one is angular node. Initially understand what is node. Lobe is there, node is there. Lobe means where the electron present or where the electron density is more. Are you getting? Where the electron density is more, that is called as lobe. Where the electron density is approximately 0, that is called as node. Understood? Where the probability of finding an electron. So in this place, there is no probability of finding an electron. Electron cannot be present here. So that place is called as node. Are you getting? So if the probability of finding an electron is 0, then it is node. If the probability of finding an electron is more, then it is low. Low it is. Understood? Okay, so listen. So low later I will explain. So in the two types of nodes are there. One is radial, another one is angular. Understood? Initially I will explain radial because this S block element, okay, S block element only as radial node or S orbital only as radial node, not angular. So listen students here. The formula for radial node is n minus l minus 1. Okay? The formula for radial node is n minus l minus 1. N is principal quantum number, l is azimuthal quantum number. So and here for angular node it is n minus 1, or you may also write it as l. So you simply consider angular node is equal to what? L. Understood? So radial node is equal to n minus l minus 1 and angular node is equal to l. I told you for s orbital there is no angular node. Why? Because l value for s orbital is how much? L value for s orbital 0. S orbital 0, p orbital 1, p orbital 2, f orbital 3. So in that L is equal to 0 for s orbital, so there is no angular node. But here n minus L minus 1 for 1s subshell, n value is 1, L value is 0. So if you apply here for 1s subshell, there is no angular node. So there is no radial node as well as angular node. Correct? So this is 1s substitution. Don't consider these two. So this is 1s substitution. Nucleus is here, electrons are here. So of course there is a possibility of electron here. There is no radial load here. Inside the nucleus, of course, there is no possibility of presence of electron. Understood? So next, consider 2s. For 2s, n value is how much? N value 2. L value 0. So according to this formula, so n minus L minus 1, that is 2 minus 0 minus 1, that is 1. So consider these two. Okay, so in between, here the electron density is more, here the electron density is more. In between these plane, only one node is there where electron cannot be possible. So in the 2s orbital, the node is 2. Sorry, only 1. So if we consider 3s also, 1, 2. 4s means 1, 2, 3. In between the shells, that is called as what? Radial node. Why it is called as radial node? When we cut the sphere, it exactly looks like a circle. Correct? Circle has a radius, hence it is called as a radial node. Understood? So what you have to remember here, initially the shape of the s orbital is spherical. So in the spherical, so orbital means what? Where the electrons present. So in that types is there. One is called as lobe, another one is node. Node is that where the electron density is less. Lobe is that where the electron density is more. Okay? In the node, two types is there. One is radial node, another one is angular node. So radial node formula is n minus L minus 1. Angular node formula is L. For s orbital, only a radial node is there is no angular node. Understood? Because L value is 0. Understood? So then, for 1s orbital, there is no radial node. For 2s orbital, only one radial node. 3s, 2, 4s, 3, like that. Understood? According to this formula, we need to find it. And where the nodes are exactly present? In between the shells. This is 1s, 2s, this is the node. This is 2s, 3s, this is the node. So if another one 4s, in between 3s, 4s means this is the node. Where the electron density is less. Understood? So remember, in this S block element, there is no particular plane. So this sphere means it can be possible in all the directions. X plane, Y plane, Z plane, in all the plane it may be possible because it is a sphere. You cannot measure the direction easily. That is what shape of an S orbital. That is spherical. So order if you want to check, students. Here this is the nucleus, this is 1s. So 1s orbital is there, 2s is there, 3s is there, and so on. Okay? So which one is larger in size here? 1s, 2s, 3s. Which one is larger in size? 3s is larger in size. So this is the order of increasing size. Increasing order of size. Okay, size depends by what? The shells. If the shells increases, obviously size also increases. Understood? So this is all about what? S orbital. That is spherical in shape. This is the energy of the S orbitals. Okay? So the next one is, after S orbital, which orbital is there? Contributing to fill up of electron takes place means after S orbital, which orbital should fill first? After S, P orbital. Okay? So listen. Second one is P orbital. So students, this P orbital shape is what? Stump shape. And remember, in the sorry, what is that? P orbital. I used to write here only one box. I used to write here three boxes. Why? Because the P orbital shape is dumbbell like this. Understood? So here we used to take three boxes for magnetic quantum number. Why we used to take this? As these are the what is that, dumbbell shape? So they can present in X, Y, and Z plane, and they are perpendicular to each other. X, Y, Z plane. Understood? So I consider three planes here. This is Z. Remember, always you should take Z axis on the, Z in the horizontal manner. Always we used to take Z in horizontal manner. Always we used to take what? X, Y, Z. That is wrong. Z is horizontal for orbital symmetry. Okay. So this may you take X, Y. Okay. One is in X plane, one is in Y plane, another one is in Z plane. Z, Y, X. So another one is Z, Y. Okay. So initially I take Px, means P orbital is present in which plane? X plane. So this is the X plane where the P orbital present. Okay. Y. So here it is Py. So here it is present in a dimension. And this one is Pz. So it's exactly present. This is the dumbbell shape. Understood? Three different planes are there. In three different planes, P orbitals can be present. One is Px, Py, Pz. So this one is, the first one is always form a sigma bond, that is Pz. We have to take horizontal. So and you know P bonds means of course it forms sigma as well as pi bond. The Z plane always forms a sigma bond rather than X and Y. That is the priority order. That is not necessary for you people. It's just remember that. Understood? Okay. So in this is the shape of the molecules in a different plane. I explained. So for this we need to check radial node as well as angular node. Here angular node is possible because as I told you, radial node formula is n minus n minus 1 and angular node formula is how much? L. Correct? For P orbital, what is the L value? For P orbital, L value 1. So one radial node is possible. So one angular node is possible here. Okay? One P orbital is not there. You know that. So 2P orbital, 3P orbital, 4P orbitals, so on present. For 2p orbital, if you consider, for 2p orbital, of course angular node is 1. So right here, wait. This is 2p, 3p, 4p. This is radial, this is angular. For 2p orbital, okay, n value is how much? N value 2, L value 1. So if you apply to this formula, what is the answer? 2 minus 1 minus 1. 0. But the angular node is 1. Okay. Here 3p. So L value is 1. But P orbital it is fixed. I told you. L value is 1. N value is 3. L value for P 1. So you need to find out L value according to orbital, not according to N value. Remember in your mind. ಅರ್ಥ ಆಗ್ತಿದೆಲ್ಲ? L ವ್ಯಾಲ್ಯೂನ ನೀವು ಯಾವಾಗಲೂ ಯಾವ ತರ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು? S P D F. S ಇದ್ರೆ L ವ್ಯಾಲ್ಯೂ 0, P ಇದ್ರೆ 1, D ಇದ್ರೆ 2 and F ಇದ್ರೆ 3. ಆ ತರ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ N 7 ಇದೆ ಅಂದ್ರೆ L ವ್ಯಾಲ್ಯೂ N-1 ಅಂದ್ರೆ 6 ಅಂತ ತಗೋಬಾರ್ದು. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? L values are fixed for 4 orbitals. N value may change. So here, what is the N value? N principal quantum number 3. N is 1 only. So according to this formula, 3 minus 1 minus 1. So it is 1. And radial node is equal to, of course, 1. Okay? And the next 4P, N value is 4. L value is 1. According to this formula, it is 2, it is 1. So in all the case, angular node present is 1, but the radial node for 2p is 0, for 3p is 1, and for 4p is 2. Understood? So why radial node is not present here? Because, so initially I told you this is the 1s orbital. Okay, in between 1s orbital and the nucleus there is no angular node. Are you getting? And at the same time there is no radial node also for 1s orbital. There is no angular node, there is no radial node. What is the reason? There is no extra shell. Here this is the nucleus, this is where the electrons present. There is no any particular region where electron cannot be present. If we take another shell, then it is 1s, then it is 2s. So if comparison is there, in between these two, here the electron is not there, so only one node is there. But here 1s, there is no p orbital. But in 2s, 2p orbital is there. Okay, so we are considering 2p orbital here. To compare with the other, there is no another p orbital here. So this is the first orbital. Are you getting? Initially 1s is there. There is no another orbital to compare here with the 2s. So initially the nodes are 0. But when we write 2s orbital, then there is a comparison between 1s and 2s. Then we can easily say one radial node is there. But here only alone 2p orbital is there. 1s compare with 1s only, 2s only, s compare with s only, p compare with p only. This is alone p is there. Only in the p orbital electrons are present. If you consider 3p, then of course two orbitals are possible, 3p and 2p. In between 3p and 2p, here there is a radial node. Here is one radial node. So next you consider this is 4p. Here 1, here 2, 2 radial node. Are you getting? Okay. So next, remember this concept. Later this can same apply for the d orbital also. So next students here, I told lobe as well as node here. So listen, this region is called as node, and these two are called as lobes. This is called as node, this is called as lobes. You remember here, you always used to write -1, 0, +1. This is below the plane, -1, this is 0, this is +1. Okay, almost the electron density at the node point is very less. They cannot be present. Okay, not this one, this one. -1, 0, +1. Okay, so this one is what? These two are where the electrons exactly present. Where the electrons exactly present. Initially I told you, listen. I'll write all these three planes in the same structure. So this is X, this is Z, this is Y. Okay? Okay, remember here. This is X, this one is Z, this one is Y. Correct? So here, this is the Z plane, X plane, Y plane. Remember. So if you write the electronic configuration, like which one? 2p6 you take. So here it is Px, Py, Pz. So initially one electron fill up takes place in which orbital? X. In X, here it is of course -1, 0, +1. Okay. So here this is the X orbital. One electron fill up takes place here. Next Y here. Next Z here. Pairing up takes place how? Here. This is how the filling up of electron takes place in the orbital. Are you getting? Okay? It's not like this. It will be like this. Electrons are going to fill up in this manner. Sometimes they may fill up. Transitions, they may be present here or here. So students, where the presence of electron density is more, those are called as lobes. So in the pre-orbital, two lobes are there, above the plane and the below the plane. Understood? So this is the center axis if you consider here. This is the axis means this is above the plane, this is below the plane. If this is the axis, this is above the plane, below the plane. So two lobes are there, one is above the plane, another one is below the plane. And of course, this is the lobe means the electrons are revolving like this, same, from here to here. That is the movement of electron. But they cannot stay at this point center. So that's why this is called as what? Lobe, where the electron density is less. Understood? And same, this is the same formula to find out radial node as well as angular node. Angular node means what? In between these two. Angle is there. Like 180, 160. Okay, different angles are there. Here, this node is there. That's why this is called as angular node. But in s orbital, this is the shape. So here, there is no angular node, only radial node is possible. Understood? Understood? Okay. Next. After p orbital, which orbital is there? So listen students, this is also order. Of course, 2p, 3p, 4p is there. So increasing order of the size and the energy is like this. 4p is more energy having and the more size it has compared to 3p compared to 2p. And remember the formula. So and also remember students, angular node is always fixed. For s orbital it is 0, for p orbital it is 1, for d orbital 2, for f orbital 3. Understood? Let us see. Next one is what? Yes, d orbital. What is the shape of d orbital? Yes, double. How many passes you used to take for d orbital? How many? 5. Okay. So what are those 5? And right here. So listen, shape of this d orbital is like this. Double. Okay. So students, here I consider again the different planes. Okay, listen. So this is z, y, x. Okay, here. So students, this is dxy plane, dyz, dzx, dx square minus y square, and dz square. So these are the 5 different d orbitals, double double. That's why we are considering different planes. Understood? So initially this one dxy means, so in the xy plane these orbitals are present. So one double that is in x plane, another one is in y plane. Double double. So here yz. So one is in y, another one is in what? Z. Correct? Next here zx. One is in z, another one is in x. Correct? Next here x square minus y square. Remember here. So one x square means x into x. Both the planes are present in x plane only. Like this. This is x and y square. X square means both the lobes double number shape is in x orbital only. Y square means y and y. Both are present in y plane. Here inside, so listen, here you can see clearly. This is one lobe. Because of the presence of another lobe, this dominates. This is how to represent sight. Here, like this, two lobes are there. Okay, and both the lobes are overlapping with each other if they present in the same. So as I told you, one present electron, also another one not having an electron. So not the same time. So this is another one. Where the electron present, here there is no electron. Understood? That is represented by like this. Here two shapes are there. Double number, of course it is. But the two number shapes are in the same plane. Z plane. Understood? So this is dxy, dyz, dzx, dx square minus y square, and dz square. So students, if we consider the radial node and the angular node here. Okay? Same I take 3 orbital starts from where? From 3D, correct? 4D, 5D and 6D. Only 4 series are there. For angular node, so we have to write radial as well as angular here. Angular node is equal to how much? L. What is the L value for d orbital? 2. So angular node is common for all the orbitals. Because it is d. Only the changes is what? Radial. Remember here, what is the L value? 3. What is the L value? L value is 3. L value 2 because it is a d orbital. Then according to this formula, what is radial node for 3D? 3 minus 2 minus 1, 0. Here 1.